boys and girls, and dad. So today I'm going to talk a little bit about correlation and relationship. So when we're looking at, and this is our first introduction to two variables. We have two variables, the amount of time you studied, what your grade is on a test. I have two variables. I want to see how these two things relate. One doesn't cause the other thing to happen, okay? But they are related, and we know that there's some relationship between them. So that in a correlation, okay, correlation is signified by little r in statistics. Relationship, r. It's not big R, little r. So we have little r is equal to, and it can be equal to values at plus or minus 1, okay? So that we have correlations ranging from -1 to +1. Pretty easy, right? Except for on the test, if you use your calculator and for some reason it comes out and it says, you know, -2.4, and you write that down as your correlation, it doesn't matter how much more of the question is right. It's clear that you don't understand relationship or correlation, and they will count it completely wrong. So be very, very careful here, no matter what your calculator spits out, okay? If it's outside this range, I want you to look at the data with your eyeballs. I want you to guess at what the correlation is. I want you to tell them why you're guessing at the correlation. I put in my calculator, I got this, it can't be that, so therefore I'm gonna guess that it's 0.8, and then just go. Just go like that's a real answer. This will get you almost every point on the test, okay? So don't get hung up on the numbers, okay? I'm gonna show you how to recognize with your eye what's right and what's wrong. And once you get that, run with it and say, give it a qualifier. It's a strong negative or it's a strong positive correlation. Which brings us to, what's the difference between negative and positive here? With a negative correlation, as one variable goes up, increases, the other goes down. And it doesn't matter which. So a great negative correlation is one that you're very familiar with. Your car gas mileage, okay, it goes, as the weight of the car goes up, the gas mileage goes down, okay? It's a negative correlation. On the other hand, a positive correlation, as one goes up, as one variable goes up, so does the other. I gotta plan better, okay? So both go up. So we would think that the more I study, the more my grades go up, okay? Or the less I study, less my grades go up, right? Okay? So that low, okay, is a thing and high is a thing. All right, so when we talk relationship, it is the correlation between two things. Can't be one thing. It's got to be two variables. And it can't be more than two variables. It's two variables. Okay? What's the relationship between these two variables? Okay? So, let's take a look at your eyeballs. We like eyeballs. You know I like the eyeballs and how the eyeballs work. Okay, so in statistics, it's why I asked you not to do the practice problems. Don't do the practice problems before you truly understand what it is you're looking for with relationship or correlation, or you tend to get all hung up in the numbers and you never truly trust your gut. Trust your gut on this. Get a good gut and then trust it. So, with a perfect correlation, okay, a perfect correlation is R equals 1. Okay, it can be +1 or -1. I'm going to do the positive first, then I'll do the negative correlations. Okay, so the positive correlation of 1 is a perfect correlation. As one goes up, proportionally, the other one goes up. So if we did on the y is always what we're trying to predict. Okay? So if I know I studied 4 hours, I'm trying to predict what score goes with 4 hours. Okay? So here, in a perfect correlation, I get 4 data points here. I'll make them bigger. 4 data points. Okay? And it's a perfect line. Okay? So maybe this is 2 hours of studying, and this is 3, and this is 4, and this is 5, and this is 70, and this is 80, and this is 90, and this is 100. Okay? Study 5 hours, get 100%. It isn't a cause and effect, it's a relationship. Okay? But a perfect correlation is a perfect line. Rarely happens in the real world. Most of the time there's some variance going on. So that in a correlation where R equals 0.8, okay, this is a perfect correlation. This is a strong correlation, 0.8. It means that if I collected a whole class, I had my class of 25, and I had 25 dots, and let's say that miraculously this is 25 dots, okay? It's not, but let's say it is, okay? So if I have 25 dots, they're all clustering in an area, and if I put a line of best fit through that data, like so, the distance to that line from any place in my data set is very small, meaning that I'm pretty confident that most of the scores are clustering about the line. That is a strong relationship. That's a strong correlation. If I go to 0.6, I get in a little bit of trouble. Okay? With 0.6, this is what we call a moderate correlation. And we're still doing amount of time I'm studying versus my test score. And now I'm going to take those 25 people in my class, and I'm going to put them in there. Okay? Still has a direction, still has kind of a cluster I can see. I can put a line of best fit in it. But it's a moderate. And the distance from the scores on the outer banks to the line, and the line is what I'm predicting, okay? Then we see that that distance is more than the distance here. Correct? Okay. So now I'm going to have a lot more variability if I'm trying to predict what does 2 or 3 hours of studying get me. Well, it can get me any score inside that range. If I go to 0.4, you're starting to get into a weak correlation. Sometimes they call 0.4 to 0.6 a moderate correlation, but 0.4 is starting to be pretty weak. And in a weak correlation, you're going to see that the score could be almost anything. Not anything, but almost anything on a line of best fit. Meaning I'm going to have a very, very wide range here of what is possible. Okay. I can't do 0.2. I've never been very good at it. We're going to skip right to 0. When the correlation is equal to 0, what we have is a perfect circle. So if I could draw, remember we always talk about this, if I could draw a moment. Not really my best thing. Oh, that's a pretty good circle though, Hadi. Okay. I'm not going to put a line of best fit through it because there is no line. It's just a circle or a blob of data. And what that indicates is that your score on how many hours you study and what your test score is, there's no relationship whatsoever. You could get any score based on how long you studied. So if you studied 2 hours, you have just as good a chance as getting 100% as someone who studied 5 hours. If this is the correlation between the two, if this is the relationship we've established between the two things. So far, so good? Okay, so what happens when we go negative? Well, the interesting thing about this is that the negative scores are directly tied to their counterpart that's positive. So that if I want a perfect negative correlation, it's a line, but it's sloped in the other direction. So this is negative 1.0, and that is also a perfect correlation. So that whenever you report the correlation, report its strength and report its direction. If you just report strength or just report direction, they'll count it wrong. Okay, give it both. So now, what happens here is I do the same thing with point A in the negative direction. And if I could draw, we would know that these two things look alike. But we know I can't draw. I try real hard, if that counts. So here I am trying to draw something, and this gives me an r equal to negative 0.8. Okay. 0.6 goes the same way, roundish, and an intersection here. Sometimes it just looks like everything's turning black on me. Okay, I get negative r equals negative 0.6, okay? Here I get negative 0.4, it goes the other way. And here is exactly the same thing. Because unlike in your calculus class, where they're going to tell you that there's a positive and a negative 0, in statistics I'm going to tell you that's not true. Okay, it might be true, but it's too hard to prove, so I'm just going to take 0 as 0. I told you we're lazy mathematicians. We square everything. We try to get rid of the negative. Well, in relationship, we embrace the negative. It tells us what the slope of the line is. Is the slope positive or is it negative? Okay? Uphill or downhill? Uphill, positive. Downhill, negative. All right, so brace yourself. We're going to have a really great, fun game to play. We're going to play this in an arena online in your small groups this week. You will understand this concept perfectly when we get done. Perfectly. There'll be no reason to memorize, no reason to take a note. You're going to get this completely when we do this, when we play the game. So I will see you on Wednesday, midday. Have a good week. Bye.